In this section, we're going to look at some built-in features of GeoGebra for dealing with differential equations. In particular, slope fields, Euler's method, initial value problems, and the GeoGebra features that are included in spreadsheets, as well as the built-in features for solving differential equations that use the slope field to visualize that differential equation. Differential equations in the first year can sometimes be thought of as derivatives that depend on both as functions of both the x and the y variable with an initial value, a value of the function given at a particular number, and that is usually referred to as an initial value problem. Euler's method is an iterative process for estimating the solution to an initial value problem in a particular number of steps, n steps. It does this by first breaking the interval between the beginning and the terminal numbers into equal steps of length b minus a over n, where a is the initial value and b is the value you're trying to solve for. And that gives us a sequence of points, numbers, between a and b of equal length. The value of the function is then estimated by, at each point, taking the previous value and adding the value of the derivative times that small change in x. If you do that repeatedly and the n is large, the step size will be small and the value at b will be estimated by the nth value. This is usually done in a table, as seen here in this table created in a spreadsheet on GeoGebra's built-in spreadsheet feature. And for this example, the derivative is twice the x minus y. We're using n equals 4. And the slope field is visualized here on the right with the a being 0 and b being 1. The estimate is achieved starting at the value 0 being 2, the initial value being 2, and the estimate being given here in 4 steps. First step, second step, third step, fourth step being 1.2656 approximately. That's visualized in the steps here shown in the line segments connecting the values from the table. And that fits pretty well into the slope field. We can use the features of GeoGebra to change the n and thereby get a better approximation for the value by changing the n to 4, 5, or 6, 7, 8, 9, and 10. So here we have a step size of 1/10, and the estimate now is 1.3947. The figure shows that the points are moving along a little bit more smooth, curve-like feature, and this direction slope field has also been modified to show a shorter slope indicator, and therefore a little more sense of what the solution to this differential equation might be.